So this is problem 6 on chapter test 9, form B. Hopefully your teacher isn't going to give you this test at school. All right, so for question 6, you have 3 parts. You have part A, that is to complete the chart. You have part B, that is to use the chart to write a system of equations. And then part C, you are going to solve the system of equations and answer the question that is asked. So in question 6, an airplane takes an hour or 2.5 hours to travel 500 kilometers against the wind. And I would like to point out that 2.5 hours is turned into an improper fraction here for the time. With the same wind, the return trip takes an hour and 40 minutes. And again, that's been converted into improper fraction form. Find the rate of the wind. So in question 1, we are asked to fill in these 3 parts. Well, it tells us the distance is 500 kilometers, so that's an easy one there. And obviously the distance back is also 500 kilometers. So there's an easy 6 points right there on your test. Then for 2, if we're going with the wind, it's the rate of the airplane plus the wind. Well, if you're going against the wind, it's going to be the rate of the airplane minus the wind. So we've filled in the table. Now we need to come up with a system of equations that's going to solve this. Now, the system of equations that I'm going to come up with aren't necessarily going to be the ones that I solve, and I'll show you why in a moment. So we know that rate times time is equal to distance. Well, here's my rate. We have r plus w, and if we're going to multiply by the time, then that's equal to the distance. Then I have my trip against the wind, so that's the rate minus the wind, times 5/2 is equal to 500. So there's my system of equations. Now, what I would first want to do is, really, I just want the r plus the w by itself. So what I'm going to do is I'm going to take a look at this table, and you could do it on the equation too, but it makes more sense if I reference the table. So the rate times the time is equal to distance. Well, that means that the distance divided by the time will be the rate, won't it? So what I'm going to do is I'm going to divide the distance, 500, by the time. So you know what? It's going to be easier if I do it not with a calculator. So if I have the distance of 500, I'm going to divide it by the time. When you divide by a fraction, you have to take the reciprocal and multiply. And so let's cross-reduce first. Does 5 go into 500? Well, it does 100 times. 5 goes into 5 once. 100 times 3 is 300. 1 times 1 is 1. So I know that the rate with the wind, the thing's going to go 300 miles, or kilometers per hour. For this one here, I know that it's going to be 500 kilometers per hour divided by 5/2. So when you multiply, or when you divide by a fraction, you have to multiply by the reciprocal. So I'm going to multiply by the reciprocal. 5 goes into 5, 100 times, so we get 200. So I know that r minus w is 200. So an easier system of equations to solve is going to, and I'm going to get rid of my work right here, so I have room to solve the system. So the system that I'm going to solve is r plus w is equal to 300, which is equivalent to this one right here. The other equation I'm going to use is r minus w is equal to 200, which is equivalent to this expression here. Well, I have opposites. I have a positive w and I have a negative w. So for solving the system, it's going to be easier to use the addition method. R plus r is 2r, w minus w is 0, and 300 plus 200 is 500. So the rate of the plane is going to be equal to 250 kilometers per hour, which makes the speed of the wind 50, because you plug it in. So you know that r minus w is equal to 200, so you have 250 minus w is equal to 200, so w equals 50. So your answer blank for this one, you can go with these two equations, or you could probably get away with these two equations. And for C, the rate of the wind is 50.